In your note packet, it says trig functions and acute angles is the title of 7.1, and we're really only going over 7.1. We're just going to break it into 3 days, and then we're going to test over that. So it says trig ratios. First of all, we're dealing with right triangles. Okay, a right triangle, how would you define to somebody what a right triangle is?
A triangle with a 90-degree angle.
A triangle with a 90-degree angle. So all of the triangles that we deal with today are going to have a right angle in them. And when we have that, we can define the sides of the triangle. We can give them a name. The hypotenuse of the right triangle is always across from the 90-degree angle. Since the 90-degree angle is the largest angle in the triangle, that means the hypotenuse always has to be the longest side. The other two sides are legs of the triangle. And we get a little more specific when we deal with the trig ratios. We're going to pick an angle, and based on this acute angle up here, this leg would be considered the adjacent. The word adjacent means next to, so this would be considered the adjacent leg to that given angle, and this would be considered the opposite leg. Now when the angle changes, so if I were to change and to move this angle down here, then this would become the opposite leg, and this would become the adjacent leg. So those two legs change depending on the problem and which angle we've designated you to use. Okay, one thing that's new from geometry, we did not use theta unless you took advanced geometry, but theta is a Greek letter that we use, and we're going to use theta to represent our acute angle that we're finding. So it just looks like a circle with a line through it. So if this is the angle that I'm trying to find, that's the one I'm going to designate as theta. Okay, so you have already become familiar with in your geometry course, whichever one you took, with sine, cosine, and tangent. But just as a review, sine is a ratio of the opposite leg divided by the hypotenuse. So if I were using this angle up here and I wanted to set up my sine ratio, I would be using the opposite leg, that distance or that length, divided by the hypotenuse length. Okay, cosine, just COS is cosine, that's the ratio of the adjacent leg divided by the hypotenuse leg. So again, if I'm using this theta angle here, this leg, this distance would be on the top. This is the adjacent leg divided by the hypotenuse distance. And then tangent is the opposite leg divided by the adjacent leg. And what we know about all triangles, all right triangles, is those ratios are the same for an angle measure. No matter, I can have similar triangles that have the same angle measure, but they have different side lengths, right? Their side lengths are in proportion to each other. That means that every 53-degree angle, the ratio of its opposite leg over its hypotenuse is always the same, no matter the triangle. Okay? So that's your sine, your cosine, and your tangent. Do you remember that? Is that familiar to you?
Yeah.
Okay. Now here's the new part. It says the reciprocal trig functions of the angle theta are formed by exchanging the terms in each ratio. To come up with the cosecant, which we abbreviate CSC. The cosecant is just taking the sine and doing the inverse of it, or flipping it, the reciprocal. So the hypotenuse value goes on top, and the opposite leg length goes on the bottom. So we kind of pair up sine and cosecant. They're just reciprocals of each other. The secant is the reciprocal of the cosine. So cosine was adjacent over hypotenuse. The secant is hypotenuse over adjacent. So these two are reciprocals of each other. And the names don't help you out. Okay, sine goes with cosecant. Cosine goes with secant. These two will help you out. Tangent and cotangent are reciprocals of each other. So if we're finding the cotangent of theta, it would be adjacent on top and opposite on the bottom. Okay, so we got 3 new ones. Make sure you access that in your packet when you need to. Okay, so what you're going to do today says write trig ratios. So given the right triangle below, write the 6 trigonometric ratios for the given angle with measured theta. So here's where theta is, up here. So we're going to write all of our ratios in reference to that angle. So you would just write down sine equals, actually it's sine of theta equals cosine theta and tangent theta. And then you're also going to do cosecant of theta, secant of theta, and cotangent of theta. So you're going to give me 6 different fractions or ratios. Jacob, put your phone away. Okay, so the sine, what's the ratio of the sine?
21.
Sine is opposite leg over hypotenuse. So from this angle, the opposite leg is 21, and the hypotenuse is 29.
So then you would just flip those for the cosecant.
So if you're going to do the cosecant, we're going to flip those around, and it's going to be 29 over 21. Yes. And with fractions, you always want to reduce your fraction if you can. 21 over 29 doesn't reduce. Cosine is the adjacent leg over the hypotenuse, so that's going to be 20 over 29. Which means the secant is just the reciprocal of that. We would do 29 over 20. And again, that's another fraction that does not reduce, but we would reduce if we could. And then tangent. Tangent is opposite over adjacent. So 21 over 20 is the tangent, making the cotangent 20 over 21.
I'm really confused.
You what?
I'm really confused.
What's that
Okay,
circle mean?
It's theta. That's a symbol, a Greek letter that we use for representing the angle measure. Okay, so if you go back, sine, do you remember SOHCAHTOA?
No.
Okay, well sine, if you go back and look on the front page, is opposite over hypotenuse. And in this right triangle, this is the hypotenuse because it's opposite the 90-degree angle. From theta, this would be the opposite leg, and this would be the adjacent leg.
So how do you know which one's adjacent, which one's opposite?
No, the word opposite means away from or across from. Adjacent means next to. So this leg is next to the angle. This leg over here is opposite of it.
Okay.
So using those, I can set up these measurements. So sine is opposite over hypotenuse, so it's 21 over 29.
Okay.
Cosine is adjacent over hypotenuse, that's 20 over 29. And tangent is opposite over adjacent.
Okay.
And then to get these are just the reciprocals. So since cosecant is the reciprocal of sine, I just take that fraction and flip it.
Okay.
Okay, so do the same thing with question number 2. We're going to set up sine of theta, cosine of theta, tangent of theta.
Do we have to draw that circle? Or can I just write like the letters and then...
Mathematically, yes, you need that circle. Check your work when you're done. Do you agree? Number 2? Did you check number 2? Any questions? Okay, do the third one. Do we agree with that one? Now, I wish one of these would have given you a ratio that was reducible, because you do need to reduce any fractions that you get.
Why
So-
can't you do the ones on that side then?
I can do these, I just can't, I'm not, reducing them is not changing to a mixed number.
Oh, never mind.
Okay, you leave it as an improper fraction. Okay, go ahead. I'm just saying that if you ever came up with the sine of theta being something like 6 over 10, you would not leave that 6 over 10. You would reduce that down and say it's 3 over 5. So because we're working with fractions, in all situations, fractions get reduced when possible. Okay, turn the page. Okay, sometimes you're given a piece of information and they want you to find the other ratios. So it says, knowing that tangent of theta is 15 over 8, what are the other trig ratios for theta? So I didn't label anything on the triangle, but I told you that the tangent of this is 15 over 8. Well, what is tangent again?
Opposite over adjacent.
Tangent again is opposite side over adjacent side. So if it's 15 over 8, the opposite leg to theta is going to be 15, and the adjacent leg to theta is going to be 8. Now, how would we figure out the hypotenuse based on what I know?
Don't they all equal 180 or something?
That's angle measures. Okay, so if I were to take the angle measures, 90 plus whatever theta is plus this one, that would add up to 180. That's true. But what about the side?
Theorem.
Pythagorean theorem. That's right. You're going to have to use a squared plus b squared equals c squared to figure out your missing side here. So if I plugged in 8 for A, 15 for B, I could find c squared. With the Pythagorean theorem, c has to be the hypotenuse. Jacob.
I'm on my
Okay.
calculator.
Okay, 8 squared is 64. 15 squared is 225 equals c squared. So if I add those together, I get 289 equals c squared. How do you find c?
You gotta
You gotta square root that. What's the square root of 289?
hold on. 17.
17. Okay, so I put 17 in there. Now I can figure out, I can write down what sine is, what cosine is, what cosecant is, what secant is, and what cotangent is.